Today's our last technique for taking derivatives. This might make a couple of you cry. I'm sorry ahead of time. This will allow us to address issues where you can't solve for y. Every one of the derivatives we've taken so far starts with an equation like y equals blah, 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 or f of x equals blah, blah, blah. But what happens when you have a function where you don't know how to solve for y? Well, we're going to use this technique called, it sounds scary, implicit differentiation. Sounds like something you have to see the doctor for. Only two things you need to worry about today. How to do implicit differentiation and the difference between there, and there. How are you on step 2? Which one's possessive? Okay, hold on, wait, stop. If we're looking at the difference between there, and there, and I say which one's possessive and you said there, it's not wrong, but it's not really the answer I was looking for. Which one's possessive? What's this? Location. This? They are. And I was feeling saucy, so I threw in an extra space there.
Should be further versus farther.
I don't know that one. You know what I also struggle with is who and whom. Anybody else? Who and whom? No, I no clue. No. Usually if I want to sound smarter, I'll throw in a whom. 4 steps to solving the implicit differentiation problem. This will mean more to you when you see me do an example, but we're going to start by taking a derivative, and that derivative is going to be a little weirder than what you've done before because you've always had them just in terms of x. That's where the term dy dx comes in, the derivative of y with respect to x. But now you're going to be taking the derivative of y with respect to y. You'll see. I see what you're trying to do there. Differentiate both sides. Move all the y prime. You'll understand what I mean in a second. Move all the y primes to the left. Move everything else to the right. Factor out y prime. Divide. You got your answer. Now you could do dy dx or y prime. I like y prime easier because it means I have to write less. If I get halfway through this, and you can eat this. If you find out that you don't like the y prime, I can easily switch back to dy. Okay, here we go. As far as I know, there's no way to get the y's out of there. If you can come up with a method, that makes you super duper awesome. Not that you're not super duper awesome. You would be super duper awesomer. But I don't know. You probably don't know, but you might. So we're going to take a different approach to this instead of factoring out. Now, if it was a simple equation and you could easily solve for y, then by all means I would encourage you to do that because then you don't need to use implicit differentiation. This, however, is a little bit uglier. It requires that you remember one simple thing. Whenever you take the derivative of something other than x, you need to stick a y prime on the end of it. Okay? So, for instance, what is the derivative of anything raised to the third power? Whoops. Let's try that again. 3y squared. Now, I took a derivative with respect to y, not x, so I have to stick a y prime on there. Or a dy dx if you prefer. Kate, what's the derivative of y squared?
2y.
Oh, y prime.
2y, y prime. Good. Elliot, what's the derivative of negative 5y?
5y prime. Wait, negative 5.
There you go. I know that's what you meant. Sedona, what's the derivative of x squared?
Negative 2x.
Perfect. Everybody see that she did not put a y prime on there because x, which is our variable. Of all of this mess on the left-hand side, the single biggest mistake that people make in implicit differentiation is the following question. What's the derivative of negative 4? You say that now, but we'll see. 0. Derivative of a constant is always 0.
We'll see about that later.
That would be step 1 in the 4 steps from the previous slide. Step 2, if it has a y prime, move it to the left-hand side or leave it on the left-hand side. If it doesn't have a y prime, get rid of it. I'm going to do 2 things in the next step because I'm feeling a little saucy. See if you can keep up with me. No, that wasn't magic. That was real math. Brian, what did I do? Couldn't have said it better myself. Thank you very much. Last step. How do I get y prime by itself? Divide. Y prime is equal to 2x over 3y squared plus 2y minus 5. That wasn't so bad, right? How could we make it worse?
Add a fraction.
Do it again? What is wrong with you? Do it again? You mean take the second derivative? What kind of sick and twisted mind comes up with something like that? This is going to be fun. Okay, so there's the first derivative. We're going to find the second derivative. Shouldn't be that bad. I already have y prime by itself on the left. I've got all that other gunk on the right. What's the derivative of y prime? Y double prime. That was easy. It wasn't so bad, was it? How about some quotient rule? You know it's going to be bad when the Gazinta bar covers half the screen. All right, here we go. 3y squared plus 2y quantity squared. 3y squared plus 2y minus 5 times 2 minus big hunk of parentheses 2x times the quantity 6y y prime plus 2y prime. Again, that's not so bad, right? I mean, we can simplify that a little bit. Six y squared plus 4y minus 10 minus 12xy y prime minus 4xy prime all over 3y squared plus 2y minus 5. Again, that's not too bad, right?
Right.
Yeah. Sure. No problem. Question, sir.
I'm just confused why is there like the y primes in there?
Because we're taking our whole basis of derivatives is based on using x as our variable, and y is not our variable, x is. So when you take a derivative with respect to y, you need to include a y prime, which says to the person, I took a derivative of this thing, y, but y is not my variable. So you stick y prime. Oh, no, that would be, I mean, that would be ridiculous. Oh, so Tom, for those of you that aren't following our discussion over here, Tom just asked, well, how do we get the y prime out of there? And I said, we're not going to. No, because that would be hideous. Yeah, that would be net. Oh, but wait a second. Hold on. Don't we know what y prime is?
Oh yeah.
Wait, no. Y prime is just that fraction above.
I'm skipping day 31.
Can't we just sub in? Yeah. Yeah.
No, it should be. That would be nice.
Tom, this is a great idea. I'm giving you full credit for this. It creates a major problem. Number one, it's ugly. Number two, the biggest problem is we're going to have a fraction inside a fraction. And that would be bad.
It's not gonna. Or are we gonna?
Of course we're going to. No, we're not. No, I'll spare you the grief. I'm running low on tissues. Too many of you would start to cry. But I will ask you this question. If I do put a fraction within a fraction, just to talk about some algebra here, let's suppose I had a function like, whoops. Why? It won't write over there. Okay, so x squared minus 1 over x plus 1/5 all over x squared minus 7. Let's suppose I had that. That's a fraction within a fraction. How would I get rid of the fraction within a fraction? Okay. Two different techniques. One method would be to take that denominator and write it as 1 over x squared minus 7 and multiply it by each one of those terms. Is that what you're talking about? Same thing with me? I'll show you another technique that you might find helpful. I would multiply this by 5x over 5x. What's 5x over 5x? 1. So we would get 5x cubed minus 5 plus x over a mess on the bottom. But again, staying with our rules, you don't ever have to multiply out denominators, so you leave them alone. So if we were to continue with that ugly equation, so go ahead and finish. I don't want to talk over you.
I'm finished.
Are you? You sure? We'll see. If I was to continue with that equation, I would get an ugly fraction within a fraction where I would have this 3y squared plus 2y minus 5 as a denominator, so I'd have to multiply the whole thing by 3y squared plus 2y minus 5 over 3y squared minus 2y, or plus 2y minus 5. Okay? That is borderline inhumane. But it's possible. You could do it. You wouldn't want to, but you could. Then, you know what would come next, right? Well, we took the derivative. That was kind of fun. And then we took the second derivative. Oh, yeah! No, I'm just kidding. No, different problem. Different problem, but probably worse. How is it worse? Oh, I've got a chain rule. I've got a product rule. I've got y's mixed in with x's. I got a big decision for you. It's okay, there's no wrong answer. Personal preference. Would you rather do the derivative by multiplying out that squared term first, you know, doing the squared first term times 2, or do you want to just take the derivative as is using the shown rule? That's right for chain rule. Chain rule? All right, let's do it. We learned it anyways, right? Might as well use it. Okie doke. 6x x squared plus y squared raised to the first power times 2x plus y squared. Nope, I lied. Already I made a mistake. I'm going to slow down a little bit here. Bring the power down, reduce it by 1. Chain on the derivative, what's inside? 2y, y prime. That's better. Equals, oh, this will be fun. Just to make sure you can follow me here, I'm going to consider 100x one function, and I'm going to consider the y another function as I do the product rule. The first times the derivative of the second plus the derivative of the first times the second. Derivative of y is y prime, derivative of 100x is 100. That wasn't so bad, right? Right? Now, the games begin. So we have to get those y primes out of there and over by themselves, which means whether I want to avoid it or not, I can't avoid multiplying this puppy out. So that would give me 6 times 2x cubed. That's the first. The outer would be 2x squared y prime. The inner would be 2x y squared. And the last would be 2y cubed y prime. I'm just going to leave this stuff. This is boring over here. FOIL method. It doesn't appear that I can add any of those together. Distribute the 6. 12x cubed plus 12x squared y prime plus 12xy squared plus 12y cubed y prime equals 100x, 100x y prime plus 100y. If it has a y prime, it goes or stays on the left. If it doesn't, it goes over on the right. 12x squared y prime, that takes care of that. Plus 12y squared, y cubed y prime minus 100xy prime equals, okay, that's taking care of everything. Everybody out of the pool. Negative 12x cubed minus 12xy squared plus 100y. Almost there. Oops. No, that's there. That's not there. Okay. So 12x squared, 12y cubed, minus 100x. Yes! Done. Okay, ready for the bad news?
No, we're not gonna guess.
I didn't need to do all that. So here's the higher order thinking question. Why did I not need to do all that? Why could I have stopped right there? Go.
Can you just plug in the numbers there?
Yeah. We know what x is. How big is x? 3. How big is y? 1, plug and chug. You get a bunch of numbers, you solve for y prime. But if you did want to find what y prime was, I think I did it correctly. I hope. And whether you plug 3 and 1 into the bottom equation, or you plug 3 and 1 into the top equation, you can end up calculating what y prime is. So for instance, we would have 6 times 10 times the quantity 6 plus 2y prime equals 300y prime plus 100. Solve that monstrosity, y prime. Whatever it may be. Questions on any of my steps up there? You can all do that, right? Beautiful. What I like to hear. We're done. How many people see that moving? Does anybody not? Interesting.
Yeah.
Look to your left. Doesn't move?
Yeah. Okay, but not when I look.
This one doesn't, but over there it does.
No, that one doesn't really. That one I think it's
I don't know, all of them. That one doesn't move for you?
Those don't move for me.
You move your eyes from like the top
That
of the
one
corner
moves,
to
that one doesn't.
the bottom of the corner to the top.
I can't get it to not move.
Just like look at the lines like this.
Just look at that, and no, it still moves over there in the
The
corner.
one right it's like weird.
No bug eyes on? No, it still
Yeah.
moves.
I
I tried though.
Keep your eyes.
Did he turn on the play button?
What's that?